You know, in the high-stakes world of uranium exploration, there's this invisible number. It's a multiplier that can add tens of millions of dollars to a company's valuation, literally overnight. It almost never makes the headlines, but believe me, it has the power to make or break fortunes. So let me ask you this. What is this number? What's the one single figure that can take a promising idea and turn it into a bankable asset without the company drilling a single new hole or adding a single acre to its property? Just think about that for a second. It's called the K factor. And if you're investing in the uranium space and you don't understand this number, I mean, really understand it from the inside out, you are flying blind. It's the critical bridge between a geological hunch and a financial reality. And the formula? It's beautifully simple. The K factor is just the amount of chemical uranium, that's the actual physical metal in the rock, measured precisely in a lab, divided by the radiometric uranium. That's what a geologist's sensor thinks is there, based on the radioactive signal it picks up. Now here's the kicker. Those two numbers, they're almost never a perfect match. So why the difference? Why don't they match up? Well, it all comes down to the unique and, frankly, kind of tricky nature of uranium itself. The best way to think about it is like this. The radiometric reading from a sensor is like an echo. It's a signal, right? A ghost of the radioactive decay that's happening down in the rock. But the chemical assay, well, that's the reality. That's when you take that rock, you crush it up, and you physically measure the metals inside. So the K factor is what connects that echo to the reality. And this right here gets to the very heart of the problem. See, unlike something like gold, uranium has this tricky dual personality. On one hand, it's radioactive, sending out gamma rays that we can detect from a distance, which is amazing for exploration. But on the other hand, it dissolves in groundwater. So over millions of years, it can move, it can migrate. It's almost like a watercolor painting that's been left out in the rain. The radioactive echo you're detecting today might be from metal that isn't even there anymore. And this whole situation really leads to three possible scenarios. First up, you've got equilibrium. That's a K factor of 1.0. Perfect. Your sensors are spot on. What you see is what you get. It's reliable, maybe a little boring. Then there's enrichment, a K factor greater than 1. Now this is the dream. This means there is more physical metal in the rock than your sensors predicted. It's like finding a hidden bonus. And then there's depletion, a K factor of less than 1. This is the nightmare. It means you're detecting ghost radiation, the radioactive echo of metal that has long since washed away. Okay, so we've covered the science. Now let's get to the good part. Let's talk about the money. This is how that simple geological number translates directly into a company's bottom line. So let's picture a junior uranium explorer. Based on their first sensor readings, they assume a standard conservative K factor of 1.0. And based on that, the market values their resource at a pretty respectable $55.1 million, okay? That's our baseline. But then they do the hard work. They drill, they take physical core samples, they send them off to the lab, and they run the chemical assays. The results come back, and guess what? The validated K factor isn't 1.0, it's 1.4. And this one single number is about to change everything. You see, because the K factor is a direct multiplier, their official resource just increased by 40% instantly. The exact same volume of rock now contains 40% more uranium, and the company's valuation, it immediately jumps to reflect that new reality, $77.2 million. And there it is, $22.1 million in new value, created in a single day. Not by finding new land, not by drilling more holes, but simply by proving what was already there. That, my friends, is the immense power of the K factor. Now, because that upside is so huge, you have to understand that the downside risk is just as real. For the serious institutional money, validating the K factor isn't just a nice to have, it's a non-negotiable requirement. It's what we call a binary event. It either makes the project or it breaks it. You really have to get inside their heads and understand what these big investors are afraid of. It's this ghost radiation. They've been burned before by exciting sensor readings that turned out to be nothing more than migrating radon gas, or interference from another element like thorium, or just those faint echoes from uranium that washed away millions of years ago. K-factor validation is the only way to prove you're chasing real metal and not just ghosts. And the difference is just stark. Before validation, what you have is a conceptual target. It attracts high-risk speculators, and it gets low valuation multiples. But after a positive K factor is proven, you have a potentially bankable resource. And that attracts institutional funds, it commands higher multiples, and it opens the door to serious financing. It's the difference between a lottery ticket and an actual business plan. And look, this isn't just about what the market thinks, it's hardwired into the industry's official rulebook. You simply cannot publish a compliant resource estimate under global standards like JRC or NI 43101 without this validation. No bank is going to touch your project, and no major partner will take you seriously until this box is checked. It is the key that unlocks the big leagues, period. So, now that you get the what in the why, let's talk about the how. Here are 3 simple but incredibly powerful questions that you must ask any uranium company you're looking at. First one is easy. What K factor are you assuming in your exploration target? The only conservative, honest answer if they don't have hard chemical data is 1.0. If a company starts bragging about a huge resource number based on an assumed K factor of 1.2 or 1.5, be skeptical. That's not a fact. That's a marketing assumption. Tell them to show you the lab certificates that prove it. Second question, when are you going to validate the K factor with chemical assays? A serious management team will have a clear, scheduled plan to get this done. If you get an answer like, oh, we'll get to it eventually, that is a massive red flag. It shows they don't have the urgency to de-risk the project for you, the shareholder. And finally, this is the pro-level question. What is the geological evidence that even suggests a favorable K factor is possible here? Why should anyone believe it will be greater than 1? They need a scientific reason, not just wishful thinking. They should be able to point to specific evidence, like maybe the mineralization is geologically young, so it hasn't had time to leach away. Or maybe there's a high uranium to thorium ratio, which can indicate that uranium is accumulating. If they can't give you a good geological reason for their optimism, it's not an investment, it's just a guess. So just remember this, the K factor isn't some obscure geological detail. It is the fundamental bridge that connects a speculative guess with a bankable reality. Understanding it, asking about it, and tracking it is one of the most powerful tools you have to separate the serious projects from the promotional gambles out there in the uranium space.